Hi, welcome to this Corbettmaths video on types of graphs. And in this video we're going to look at a particular type of graph which looks at the depth of water in a container and how that changes over time. And in this video we're going to look at what happens whenever we're filling up empty containers. So if we had a container that looks like this with vertical sides, and we had an empty container to begin with and we started filling it up at a steady pace, so in other words we've just turned our tap on and we're letting it run at a steady pace, and we started to fill up this container, what would happen? Well, to begin with the container would be empty, so at the very beginning it would be empty, and then the height of the water, the depth of the water would just steadily increase. After 1 second the depth could be 1 centimeter, after 2 seconds it could be 2 centimeters, and so on. So it would be a nice straight line like so. So it'll be a straight line graph that looks like that, where it starts here at 0, 0, and it just increases steadily. After 1 second, the height might be 1 centimeter. After 2 seconds, it might be 2 centimeters, and so on. So this container has vertical sides. If we brought those sides closer together, so it was a narrower container, this graph would be steeper. So it would still increase at a steady pace, but it would just be a steeper line. And if the sides of the container, these two vertical sides, were wider apart, it would be less steep. So it would look something like that. Okay, now let's have a look at another container. So again, this container still has vertical sides. You can see here we've got two sections. I'm thinking of perhaps like a vase or a perfume bottle or an aftershave bottle or something like that. So we've got these two sections. We've got this wider section at the bottom and we've got this narrower section at the top. Now, if we had this empty container and we started filling it up with water, what would happen is it would start filling up, but it would be quite slow to begin with as it starts filling up this section at the bottom with the wide sides. And then whenever you get to here, the section at the top, what would happen is then it would start filling up more quickly, and the depth of the water would just start rising up more quickly, like so. So the graph would look something like this, where to begin with, the depth of the water is increasing, but it's increasing quite slowly, and then whenever you get to this neck of the vase or the neck of the aftershave bottle or whatever, it then starts filling up more quickly, so the depth of the water starts rising more quickly. So we've looked at containers with vertical sides, but what happens if the sides of the container aren't vertical? So here we've got a container and it's empty, and we're going to start filling it up with water, and as you can see it's narrow at the bottom, but then it gets wider and wider and wider apart, so it's furthest apart at the top. So whenever we had our previous one, the depth of the water increases slowly whenever the walls are far apart, but whenever they're closer together, the depth of the water increases more quickly. So here, at the very beginning, we know that the depth is going to be 0 at the very beginning, and as the sides are getting wider and wider and wider apart, that means that as we're filling this, it'll sort of rise up, but then as time goes on, it'll take longer and longer and longer and longer for the depth of the water to go up, because obviously as it's further apart, it's going to take more water to fill up. So what's going to happen then is the graph would look something like this, where it's filling up to begin with, and it's filling up at its quickest pace just at the very beginning, but then it's always getting slower and slower and slower, so it takes longer and longer and longer for the height to increase. So it's going to look like that. It's going to be a curve, and it's going to curve like so. But what happens then if the container looks something like this? And I'm sort of picturing a sort of a conical flask or something like that in science. Now, I hope I've got that right. But I've got memories of some sort of flask in science which looks something like this, where this container, as you can see, it's furthest apart at the bottom, but then it gets closer and closer and closer. So if this container was empty and we started filling it up with water, it would fill up slowly at the beginning, but as the sides are getting closer, it's going to take less time for the height to increase. So as it gets narrower, the depth of the water increases more quickly and quickly, and our graph would look something like that. So if the container is getting wider, the curve will look like that because it'll take longer to fill up. And if it's getting narrower, so in other words, if the container is getting narrower at the top, so the depth will increase more quickly, the curve will look something like that. So let's have a look at our next container. So here's our next container, and as you can see, this container's got two different parts. It's got the section at the bottom with the vertical walls, and they're quite far apart. And then the walls start getting closer together as you go up the bottle. So at this point, the walls start getting closer together. So in other words, it's narrowing. So the graph would look something like this. So at the beginning, it's a straight line. As you start filling it up, it'll start increasing, but at the depth of the water, it'll increase quite slowly. And then you get to this point, and then the container starts getting closer together. So what happens is that it starts increasing and going up a bit faster and a bit faster and a bit faster, and the depth of the water just goes up a bit faster and faster, and it looks something like this. So it'll be a straight line to begin with, and then the depth of the water will go up faster as time goes on. So as the time goes on, the depth of the water goes up and up more each second. Okay, let's have a look at our last example. So our last example, we've got a container that looks like this. And as you can see, the walls of the container are curved. So again, if you look at it, we've got kind of two sections of this container. I'm thinking of some sort of vase or something like that. You've got the bottom half of it, and you've got the top half of the container. Now, if you look at the bottom half of the container, it starts quite narrow, but it gets wider and wider apart. So that means that the depth of the water will go up, but it'll be going up more slowly and slowly and slowly and slowly as the water's being poured in. So as the walls are getting further apart, it goes up more slowly. And then we get to this point. And at this point here, you can see the walls of the container start getting closer and closer together. They start sort of curving in, so they start narrowing. So that means that it'll be filling up, but then as you start going up, as the walls get closer, it'll start filling up more quickly. So the graph would look something like this, where the depth of the water, it goes up quite quickly at the very beginning, but it's slowing down. It's always slowing down as the walls are getting further apart. So it's slowing down, slowing down, slowing down. So then you get to this point, and that point then would be in the middle. And then as the walls start getting closer together, so as they start curving it, so at this point the depth of the water will start going up more quickly and more quickly, and it looks something like that.